Hello, everyone. My name is Álvaro González. I'm from Skoltech in Russia. Project that we did with some Colombian and Spanish colleagues related to the economic impact that has the integration of wind generation in the Colombian electricity market. Okay. To understand this work, we need to talk a bit about how the Colombian market is composed. So the electric system is mostly supplied by hydro generation, as you can see here on the left side of the figure in the reference of 2017. And about 80% is hydro, either by reservoir or by run-of-the-river generation, which means that the country is highly, let's say, dependent and subject to climate issues, as we will discuss later. In order to mitigate this and to diversify more the generation matrix, the government has decided to put for tender renewable generation projects, mostly related to wind generation and photovoltaic generation. So by 2030, it is expected the increasing renewable capacity from around 100 megawatts that we have today to 2.5 gigawatts, so 25 times the amount of renewable would be increased. So, and this is important to analyze because most of the generation of the country that is hydro is located in the center of the country, where we have a mountain range and where the most populous cities are located. And if you can see here in the map, in the northern part, we have like 3 main points where we have gas generation located in other metropolis, but they are connected to the center of the country through transmission lines, making there being basically 2 different price zones in the country, where you have cheap electricity in the center and then expensive in the north. As we see right in the very tip of the country in purple with white, here we have all the planned wind installation. And this is because we have here a desert with high wind potential. So all of these projects, about 2 gigawatts, are going to be installed there. And this is the point that we're going to consider for our analysis. The main challenges of the system, as I mentioned before, is that we have mostly hydropower generation, which makes us vulnerable to climatological issues such as El Niño phenomenon that causes the droughts throughout several months of the year. This increases our dependence then on backup fuel generation and can even lead to shortages in the electricity supply, as has happened in recent years. We have a transmission congestion problem, since we have most of the generation located in the center of the country. We have weak interconnection with other countries. Currently, we are neighbors with about 5 countries, but we only have interconnection with 2 of them, Venezuela and Ecuador, and only 1 of them is active. And finally, even if we want to use higher photovoltaic generation capacity, this would lead us to still trying to solve the problem of the peak load that is occurring during the nights. So for our analysis, we decided to study the regulations established in the Colombian electricity market, and we modeled this, all of the, let's say, laws and let's say technical calculations that are required for operating this market. Additionally, we estimated the wind generation based on historical data of the location that I showed previously in the map in the north of the country. And we decided to basically take the measurements that were recorded in this site for a year, so we could use real data to simulate the impact in the Colombian market. So we are not forecasting or using probabilistic methods to see what would be the optimal operation, since the market is run in a deterministic manner. So that's why we decided to go by simulation based on historical and real data. Additionally, we then introduced this wind generation, the one that would have been based on these measurements, in order to assess what would be the economic impact and also the operational impact in the other type of generation units. So based on this, we can build a unit commitment model that is going to be run based on the data of the reported generation for those specific days, since each one of the generation plants has to report different technical parameters that were also considered based on real data. So we have the ramp limits that were registered for each one of the different days, the minimum operational time, the minimum capacity and maximum capacity that could be changed day by day by the generation plants. Additionally, the unit commitment model in Colombia includes the reserve allocation. So we did this based on the current legislation. Okay. For our analysis, we use 3 base cases. So the first one is case A, where we have no wind generation installed. So it's similar to the current one, where we only have less than 100 megawatts that are not even connected to the central system. Then we have case B, that is around 500 megawatts. That is the approved projects right now that are going to be built, so the ones that have been assigned. And then we have double that is expected to be assigned in the next year. Okay, here in the figure, we can see that for the different cases, as expected during the low demand hours, so from midnight up to 6 a.m., the electricity price that is called in the regulation, the market spot price, is lower for higher wind penetration. However, this is not maintained during the hours of high demand, given the different ramping requirements that the wind introduces in the system. Okay. Additionally, we evidenced that the generation cost per generation technology is fairly constant for the coal generation, since the country produces a lot of coal, and also for the small hydro or run of the river that has a cost of 0. However, for the gas and for the hydro generation, these costs change throughout the year, given that the gas is independent of the international gas prices, and that the hydro generation is dependent on the reservoir levels. So if we are in a dry season, as happens in the middle of the year, then the reservoir levels are lower and the price increases. Okay. As here we did a sensitivity analysis of what would happen if we are increasing, let's say, stepwise the wind capacity installed. As we can see, basically all the other generation types reduce their participation in the market, since the wind is entering, but we see a high variability in hydro and in gas generation. So that means that they, as the different wind scenarios are occurring, they are also fluctuating with them, which indicates that the hydro and gas generation are the ones that are balancing the wind generation. So they are the ones covering the ramping requirements in the system. In this figure, we can see how this generation, the share of the generation changes with the increasing of the wind capacity. And as we see here, after some point around 700 megawatts, the coal generation is removed, decreases and then is removed from the system, given that it is too slow and expensive to answer to the ramping requirements introduced now by the wind generation. And this actually leads to the disconnection or the non-utilization of some generation plants, such as we can see here, 2 examples from 2 different technologies. So this gas generator and coal generator, that basically they are too slow and too expensive to compete with the new requirements that are introduced by the wind. So in conclusion, we presented a detailed study of how the Colombian electricity market works. That if you want the details with the laws and the references, you can find them in our paper. And we wanted to analyze what would happen, or what is going to happen with the introduction of wind in the northern part of the country. The increase of the wind penetration is going to result in the lesser utilization of some fuel-based power plants, especially those that are slower to respond to the ramping requirements. We see that the hydro generation can provide some support to the wind generation for providing ramp response. However, given that the hydro generation is dependent on the climatological factors and cyclic phenomena, then policymakers need to take this into account when they want to assign the new renewable generation projects, especially considering the capacity of the transmission corridor, so we don't have a negative impact when we have the dry seasons for extended periods of time. So this has been it. So thank you very much. And if you have any questions, please, I'm all ears.